Hi again, let's keep going. The next thing we're going to talk about is this range of pins. It's labeled analog in on the board. And let's look very carefully at the numbering scheme they've used. This is actually pretty typical for electrical engineering and computer science. They think they're so cool, and so they like to start counting with the number 0. So sneaky. So there are numbers 0 through 5 here, but please note, this is not just the number 0, it actually says A0. So pin's number is A0. This pin's number is A1, A2, etc., all the way through A5. There are not 5 of them, there are 6, because though 5 is the highest number, we started with 0, so don't let that confuse you. All 6 of these pins, and they have very helpfully written this label on the edge of the board. If it's in focus, it's even easier to see. Come on. It says analog in. So that's true. They were not lying. These are the analog input pins. So what is the meaning of that? Well, let's take a moment to draw a distinction between analog and what is the counterpoint of analog. So essentially, what I want you to think of is analog is something that is dimmable, something that has a low, a high, and a bunch of stuff in the middle. For instance, a dimmer for a light, or a volume knob, or something like that. Those are analog adjustments in the sense that they take a wide range of possible values. Digital, on the other hand, is the thing we're going to compare analog with or define it oppositely. Digital has 2 possible states. It's like a light switch, on or off. There's no middle state for a light switch. It's either switched on or off. We'll call that a digital device, and I am using the language in a slightly sneaky way here because that's not really precisely what digital means in its fuller sense. But for our purposes, it's an important distinction to draw between analog, wide range of values, and digital, only 2 possible values, typically be on and off in the world of electronics. Another point I want to make, I have been referring from time to time as all these things, all these places you could plug stuff in, I've been calling them pins. But that's kind of a peculiar nomenclature because if you look at them, they're places that you plug stuff in. It's kind of like a socket in the wall where you would plug the plug into the socket. And so you shouldn't break your pencil lead off in there, but you can imagine the pencil lead's going to stick in. So it's kind of like this is the plug and this is the socket. But I'm calling both of them pins. Well, they are both in electrical engineering called pins, but we have to distinguish between this kind of a pin and this kind of a pin. So this is a pencil, you shouldn't stick it in there. Here's an example of a little jumper wire. A jumper wire is included in your kit probably, or you've got some handy, hopefully. They're very useful for making connections. We use them all the time. A jumper wire like this has a thing sticking out of it that can plug in like that. So we would have made that connection. So the electrical engineers had to come up with names for these things, and they decided to follow the biological paradigm. Namely, this is called a male pin. This is called a female pin. And this, believe it or not, is called mating. So the heteronormative electrical engineers in days of yore, that's the language they selected. And if you have confusion about that, I invite you to make an appointment with the school nurse. Next, we're going to learn more about digital pins.